Oracle database technologies, including REC, Data Guard, Golden Gate, and performance tuning. Additionally, is quite a deep knowledge of Oracle engineer system, such as your Exadata Cloud at Customer, also OCI architecting and solutioning. Habib also has held a position of Oracle pre-sale solution architect, leading the Oracle engineering system initiatives for central governments and enterprise customers across India. So I'd like to thank you, Habib, for making yourself available to us. We know it's a bit late on your side, but we thank you for making yourself available. And we will also like to welcome all our colleagues on this call. So Habib, we hand over to you.
Thank you, Mose. Thank you very much. Let me share my screen. Allow me a minute. Okay. So, good evening, guys. In fact, good morning for me. Right now it's 9:30. So good evening, good morning. Okay. So, mostly I told about me. I'm the Habib and working as a Oracle database technology as a product manager for Oracle globally distributed database and the True Cache. So today we'll talk about these two topics in detail. So nowadays we have concept called distributed database. So Oracle has built up new technology called Oracle globally distributed database. Now, what exactly the distributed database is? Like, it is a database that stores the data across the multiple physical location instead of one location. And each location stores a subset of data. And physical distribution, the physical distributions of the data is hidden from the application. Now, the Oracle database, it became a distributed database in 2017, where the native database sharding was released. Now, today it powers many critical distributed applications around the world. You can name it: mobile messaging, credit card fraud detection, payment processing, personalized marketing, internet infrastructure, and smart power meters. All these are area where this particular application database is, powered there, being used there.
Excuse me,
Now
Habib,
that,
just a bit. Can you please share your screen again?
okay.
Thank you.
Yeah. So there are two main use cases for distributed database. One is ultimate scalability and the survivability, and the second is called transparent data sovereignty. Now, ultimate scalability is basically the data is distributed and replicated across databases for the hyperscale and the fault tolerances. Now, second is transparency of the transparent data sovereignty. Now, each country's data is stored in a country to help implement the regulatory requirement. This is basically the customer who wants the data to be distributed in every country. Like suppose in India's data, India, US and US, South Africa and South Africa. So this kind of option, if you required, that it can be done by this one. So every country's regulatory is met and the application can smoothly work. Now, let us deep dive into this. Now, an Oracle globally distributed database is normally called a single logical database. Now, data is physically distributed across multiple databases. You can see my screen. We have right side. We have something called shard, so which we call shard, and data in the each shard is replicated for survivability. Now, all shard can process the application request, and that's why we call it is active architecture. Data can be redistributed across the shard, across data centers, across the regions, and across that like multiple zone, while the database is still up running actually, right? Now, the benefit of the sharding, the other name is called sharding. The sharding, I told you this was introduced in 2017, but now we call as a Oracle globally distributed database. Now, these are three main areas where this is benefited. One is hyperscale. Now, adding the shards online to increase database size or throughput is in fact online. There's no need to do any kind of downtime. And the fault isolation, like break the monolithic concept. Like fault of one shard has no impact of the shard. In case one shard goes down, you still have the 2 shard, 3 shard to support your business, right? And the third is called data sovereignty. Now, data 70 told you this is user-defined data placement. Like you have the options to create the data 70, and you have the option to place the data of your country in the respective shard. Shard, nothing but told you, is a physical database, actually, right? It's a physical database. So these three are the main benefit you can see here that serve the purpose of your hyperscale, fault tolerance, and the data 70. Now, if you see here, the distribution of data is hidden from the application. Now, the biggest advantage here is we have this feature built in. The application doesn't have to worry about it where the data is coming. It is distributed across the multiple shard, and application requests that only needs data from the single shard are transparently sent to that shard directly. I mean, application doesn't have to worry about it. It just have to just write the query, click and this, you get the data. How it happened internally, that is Oracle has made this good thing, is transparent actually. Now, requests that need data from the multiple shards, suppose you require data from multiple shards, that are automatically split to multiple requests, and that are sent to appropriate shard, and it's committed automatically. So here, when the multiple shard concept comes up, here what happened? The data request goes to all three shards. Internally, it gets something called the scatter and gather. It is scatter the request to all two shards. It processes parallelly. It gathered the information and aggregate it and send back to application. Now, queries can be parallelized both within and across the shard to implement the massive parallel analytics. Now, this is the next generation for the big data, right? Now, let's go detail of the example. I mean, what exactly mean by data 70, in fact. Now, data 70 is becoming the mandatory in India for the payment data. The Reserve Bank of India, it has made a kind of localization regulatory. It says that if the payment data reside in the India, in the both payer and payee in the same entity, then data should be remain there actually. Like suppose India's data in India's country, South Africa data in South Africa country, US data in US country, right? So this is regulatory of every country actually. Now, this could be in fact, this is now becoming a kind of showstopper for the global financial services companies that store the data of all country in the single databases. Now, right now it's happening same thing, like all the countries' databases there in single part. But here is not like this way. Now, the key observation from here is the data must be stored in India, but can be accessed from anywhere. This is the beauty of the this distributed database. One of the biggest, largest bank in US had to re-architect their payment database to satisfy these regulations. Initially, what happened is that all the worldwide payment data was stored in the US on their Exadata machine systems. And the application and the database TS were replicated across the region inside the US for the data disaster recovery. So what we did is, the Oracle Global Database, it enabled the bank to easily comply with India's regulations. What we did is, with the new shard, we created in India that hold the India data, and the new database architecture, which required the minimal application changes, the complex, highly complex application tier architecture did not to be redundant in both countries. It means the application should not be placed in both countries, India and in the US. Could be anywhere. It can be accessed from where. Well, data got distributed in US part US data, India part India data. Now that was example. Now, second example you can say is the Belukai is a leading data platform for digital marketing campaigns, right? So where you normally you access the data in the real time. Maybe if you see this when you do surfing, right, there this can be used. So access in the real time data by hundreds of millions of consumers as they serve the internet. Now what we did is, this Belukai is basically hyperscale workload, which runs the multi-petabyte databases, and there requires that the response should be very instant. Now, for that, it is implemented now. Right now, we're getting almost more than 1 million transactions per second, and every day around 30 billion API calls we're getting, and the response time for API call is less than almost 1.5 ms. And this Belukai runs on Oracle globally distributed database with the community server, which have around 104 community server, and 5,408 CPU core with 77 terabyte of memory. Initially, it was migrated from combinations of Aerospikes Cassandra, and the Scala. Now, these are the platform where this was running initially, but now it has moved to Oracle globally distributed database. Now, more detailed, Buluka, we can share the PPT, you can read from here. The simplicity of this new architecture puts the power of SQL, Oracle SQL, which enables the Bulukai to innovate many times faster than the before. Now, look this architect here. We have three data center out here, data center 1, 2, 3, and then we have 1 to 3 here. So this is something we can say replication center. So distributed around 3 data centers. And if one data center goes down, you still have the remaining 5 data centers to serve the traffic. And the size of the data is somewhere more than 2.5 petabyte right now. Now, Oracle has more data distribution method than any other distributed database. Now, the purpose behind this, we are matching the distribution method to need of the application is critical for database distribution. Let's see what exactly we have. Now, let me tell you what distribution is this. When you design the Oracle sharding, you need to distribute the database data in the sharding in some fashion. So Oracle supports basically 4 types of the data distribution method. One is called system managed sharding, which normally use consistent hash as a background with algorithms. Second, we use something called user-defined sharding, where you have the control to place the data within the shard as per your need. And third, we call composite sharding, which is normally the combinations of the system managed and the user-defined. And the fourth we call as the directory-based sharding or the fine-grained-based sharding. So now the value-based distribution of only the list are the range, in fact, here. For example, we want to shard based on the country code or maybe phone number. Now, system-based sharding distribute by using something called consistent hash. There is a option called Aura hash. We check this. Aura hash use internally hashing algorithm to distribute the data on all shard uniformly. For example, customer ID, device ID, XYZ. Composite distributed database basically has 2 levels. The first level, we use the user-defined sharding that use the range or the list of values. And the second level of sharding, we use something called hash function customer ID. You see my diagram here, actually, we have 3 countries, US, EMEA, India. So first we distributed by the list, this is called these 3 countries. And then within each country, we have something called system defined. So every country has a customer ID. So hash 1, hash 2, hash 3. And similarly, within that, the last diagram you can see here, we distribute the composite way. The composite basically has the combination of user-defined sharding and the system-managed sharding. Now, Oracle also support the user-defined distributions. Now, in the Oracle defined, like the defined distribution, user-defined distribution, sorry, used when the data requires special handling, such as the skewed data. Now, for example, you can store, this is my diagram here, you can store the Taylor Swift and the Beatles data in their own shard. Like Taylor Swift data is in red shard and the Beatle data in the blue shard, like it's a green shard. And the lumps, we can see the other artist data, which are not the popular, that can store maybe in the blue shard. So this is thing where you can place the data placement based on your requirements. So you have the full control to place the data which country you want to be, right? So this is what we call the user-defined sharding. This is where the data sovereignty come to picture, that you want to store the India's data in India, South Africa data, South Africa used in the US country. Yeah. Now, there's one more concept called support duplicated data distribution. Like in the Oracle sharding, we shard the database. In fact, sorry, we shard the table based on some particular, shard ID, maybe your customer ID, transaction ID, voter ID, something in fact, right? So based on some key, we shard it. But there are some table very small in the size. You can say maybe very small is maybe product table, which hardly has few columns. So for such table, we don't need to shard them. We can place directly these duplicate table into respective shard. Maybe you can see here, the first shard, second shard, like US, EMEA, or India. In all 3 shard, we can put this duplicate table. But sharding, which we do is that we distribute actually. So smallish table that are read mostly can be duplicated across all 3 shard. And this is used to avoid any cross shard queries or cross shard the efficient ticket checking. So this will be help us to do the local joining much faster instead of sharding them. Now, along with this, you have the options to do online addition and automated data distribution across the shard. In case you want to add some shard during the database runtime is there, you can do it. There's no need to any kind of downtime. So the moment you add the new shard, automatically the data from the other shard get redistributed. So to scale out or scale in, shard can be added, removed, right? And data across the shard is automatically rebalanced within the data movement file. So there's no any kind of user intervention required to do this thing. It does automatically for you. This is the online operation. It doesn't require any kind of incur downtime. In fact, it is in fact very fast. Now, Oracle has more replication method than India distribution method. Like if you see here, Oracle normally support two types of, like distribution method, replication method. One replication we call as the golden gate, right? It's a very famous one. And the second replication method we call is the ADG, Active Data Guard, right? We also call data guard. Now the third one Oracle introduced called raft-based replication in 23i. This is a feature of 23i, not the 19c. In the 19c onwards, in the previous version 19c, we had ADG and the golden gate to do this sharding activity, replication activity. But in Oracle 23i, we had a raft one. Now raft is not something new to us, in fact. Because raft is already existing. It's used by maybe Google Spanner, it's used by Yogabyte, CockroachDB, multiple they use it. But the way Oracle has defined it, the way Oracle has defined it, recreated it is something very different. Oracle has made it this very different way. It works in a very different way, but it is much faster, much efficient than our competitor actually. So now a raft-based application, basically it works on something called quorum-based consensus, right? Maybe you must be doing these things. There's a concept called leader and the follower, right? So one leader, multiple followers. So once the majority of followers, they say we have ready to commit the data, we have received the data, then the leader commit the data. This is something called quorum-based consensus. Now, new replication method that use the popular raft quorum-based protocol, it provides the automatic failure to specific replica in under 3 subseconds. If I say 3 subseconds means it's starting from application to DVA level. In case if one of the shard goes down due to some issue, right? Automatically, the remaining shard will start taking the traffic, and the shard which is down, it comes up within a sub 3 seconds. So thing is, the beauty here it is, I mean, we have tested in our case in the POC. We have done so many POC right now, and doing a POC right now. We have seen the failure is also even less than 3 seconds. Some customer we have 1 second, some customer we have 1.5 seconds. So that actually is there. And it implemented as an active symmetric configuration, because here all the shard has the leaders. So leaders, one who accept the right. So every of the shard is called active. Means every shard has a capability to accept the read and the write request. This is what we call active. If you see in the case of a data guard, we call active passive, because one is a primary is standby. In the case of raft replication, is all active. There's no standby, all primary. Okay, that ensure that you have the application ability, whatever you like, information you want, all the shard which you have, it's ready to serve the traffic. Now, second is zero data loss. This provides a high performance for synchronous replication method, because within the shard, within this, if you see my diagram, DC1, DC2, DC3, it works as a synchronous, right? Now, the active global scale database. Now, database sharding with our application. Now, the built-in replication which integrate the transaction executions, and fast automatic 3 subsequent failure with the zero data loss. Now, as I told you, this is called active symmetric configuration. Now, each shard, if you see my diagram here, each shard accepts write and the read for the subset of data. And no need to configure the ADG or the golden gate for the shard. It is by default the new method of replication called a raft-based application. Other thing is this, shard uses, what will happen is, the sharded database is divided into multiple replication unit called RU. Now, RU nothing but says nothing but a replication unit, money. Suppose how many replica you want. So right now we see my diagram, we have 3 shards, so we need 3 replica. Replica 1, 2, 3 actually. Right, it means 3 copy of the data, right? Replica of RU is split evenly 3 or more shards. And each shard is a leader, the primary of the sum of RU, and the follower for the SIG. So every shard, one, if you see my diagram here, the green one is a leader out here, and this below color, this is this is pink color, what do you call this color, and this blue one, this is called a follower. In the second shard, this red color is the leader, and these two are the followers. In the last one, last is leader, these two followers. So leader has the power to accept the read and write, and the followers only read the data. So any case of time, if your application connect any of the particular shard, you'll get the data. And it guarantees a consistency among the application in the case of failures, or in case of network partition, or in a message loss or something. You is guaranteed that you get the data. There will be no loss of data actually. And in case of any shard goes down due to some issue, it automatically get reconfigured after the failure is detected. And once it is back to the like a raft cluster, data gets automatically redistributed here. Now, these are the two different types of replication method which we have. I think you guys know very well. One is called the active data guard, which is normally called fast performance, most complete SQL functionality, readable data, simple operation. But only thing here is, in the case if the primary goes down, there could be time required to bring the standby, right? So there would be some kind of time delay, maybe some gap will be there. The second level we call the golden gate. Even this also provides the fast failover. But yes, I mean, in both cases, only thing is like in the case of golden gate, it includes the conflict avoidance and resolution that is there. But in the case of RAF replication, this feature by default built in there. So these two also we have the option called replication. But the one we talked about, the previous one, the Raft was, this is something new in Oracle 23i only. We don't have in the previous version. Now, in the Oracle, when you say we have, let's say example, if we want to do the sharding, right? So question comes into which are the table you want to shard in. Shard means you implement the sharding concept. So the table which is going to involve or which is going to exist in this sharding method scheme family, that is called the table family. So here you see my example, the customer orders line items. These are three tables we call table family. That is what we're going to shard it, right? Now, below we have something called product table. Now the product table is not sharding. This is called the duplicate table. So we are replicating the same product table in all the shard 1, shard 2, shard 3. The right side you can see we have three shard 1, shard 2, shard 3. And just to make understanding purpose, in fact, we have taken three table out here as example, but we can have thousands of table in the sharding. There's no limitation. So here, the customer orders and line items. We have three tables. So to simplicity understanding, we have sharded the customer ID, right? Now customer ID 1, 2, 3, 4, 5, 6, 9, 9, 9. This is a sharding key. Now see here, right side we have the your shard. So if you see the Mary's sharding ID is 1, 2, 3, and Mary's data lies in the shard number 2, right? This red shard. Similarly, the John data 4, 5, 6 is a customer ID, lies in the shard number 3. And Peter's user ID is 999, lies shard number 1. So now here, when you use the system defined sharding, your system managed sharding, you can say. In that case, based on the consistent hashing algorithm, it plays the data of the sharded table into respective shard, in fact, based on. So here, the good thing is this, okay, like this is distributed here in case you want to find any particular, let's say, table, any query, in fact. If you say, get me or select star from EMP where the customer ID is 1, 2, 3. What happens? The sharding also has a concept, also has a part called GSM. That is what you call the global listener or remote listener. And we also have something called shard catalog. Shard catalog is basically called your meta source actually. So the moment you write this command, select a star from customers where the customer ID is 1, 2, 3. So 1, 2, 3 means you define the sharding key. The moment you define the sharding key, the GSM which is there here below of this particular like shard, it knows because GSM has a buffer. GSM knows this sharding ID 1, 2, 3 lies where. So directly he can say, pull the data from shard number 2. Similarly, say get the detail where the customer ID is 456. Straight away, GSM will say this particular shard ID is lying, shard ID is data lying under shard number 3. So this is something we can say the two way of talking is called direct routing and the proxy routing. We see later on this chapter. And the product table, which told you, this is something you can say is a duplicate table. Now it is very small in the size. We don't need to shard it. So what we do, we place it in separately in all the shard, like shard 1, shard 2, shard 3. You can see this gray color, right? This is called duplicate tables. Now, this is what I was talking about. We have two way of like routing the application work request flow. One is called direct routing, and the second is called proxy routing. Direct routing, basically what we do, we provide a customer ID straight away. Let's say customer ID is 1. So if I say select start from customers where the customer ID is 1, now the GSM knows the customer ID 1 lies the shard number red. So directly give the output here. If you say similarly service start from customer where customer ID 301, it knows this lies on the like blue shard. So direct routing, we know exactly where the particular data lies. But in case you do not mention the sharding key, like example is a proxy routing here. Say select the start from customer. Now, when you do this thing, what is going to happen is all these 3 shard, in this case, this is something you say this one call as your query coordinator, or you can say it is something called multi-shard coordinator, or you can say it is a shard catalog, right? Now, this shard catalog, basically what happens is, it creates automatically multi-thread request on all 3 shard. It does something called scatter the request to all 3 shard. It get process them parallelly, gather the data, aggregate it, and send back to application. So this take one extra pass. Performance perspective, there's not much difference because direct routing work much faster. But proxy routing maybe take one extra pass, but there'll be one much different in performance. So these two are the method through which we pull the data from the direct routing and the proxy routing, depending upon the sharding key you have mentioned. Now, the second thing is where do you deploy this particular distributed database? So we have multiple options to deploy a database. Now, you can deploy your Oracle shards across on the prem, on cloud, on multi-clouds. In fact, you can also have options, one of the shard in the OCI cloud, second shard in the AWS cloud, and third shard in Azure cloud. And the fourth could be in your maybe on-prem. This kind of capability, nobody has it in the world. In fact, any competitor, they do not have this thing. Because so you can choose the deployment option here. Now, can optimize the scale needs and cloud availability for each country. So this is the one thing we have, which is a unique thing. Now, next is I told you Oracle globally distributed database also it also brings something called natural language, right? The natural language is basically is a feature of the Oracle Select AI, right? This is a autonomous database Select AI that can translate the natural language like you into SQL. See the left side, right side, we have option something called how many total stream for each Tom Cruise movie were viewed in India this month. Now this is the your call LLM, natural language effect, right? Now this large language model, based on the algorithm, it will create a kind of language called SQL language, and this will be read automatically by the machine itself. So you don't need to write this SQL. In the case of Select AI for autonomous database, you don't need to write any kind of SQL. You just write this statement, the natural language statement, automatically in the backend, the LLM gets generated and you get the output. Similarly, we have something called AI vector search in the rack. This is again 2 new things we have on Oracle 23i. So Oracle distribute data with hyperscale and data 70 that use Oracle 23i array vector search. And this can be combined both similarity search because AI vector search is a part of 23i where you can compare the 2 similar picture, right? Like say you have some picture, you want to see how this picture, let's suppose you bought a house here in one place. You want to see the similar picture of this house where existing. So there's something what you call the vector uh, AI vector search. Now, the last one is something called, we have called autonomous database, right? So Oracle globally distributed database plus autonomous database that gives you a new offering called globally distributed autonomous database. The best part is the simplest thing, most functional, and most mission critical. It is cloud native distributed database services in the world, which has serverless elastic, auto-scale architecture, and dramatically lower cost, because the all operational complexity is being eliminated and being managed by the autonomous database automatically. Okay, so takeaway from here is global database. We have two ultimate kind of use cases. One is called ultimate scalability and solvability, and the second is called transparent data sovereignty. Okay, so this ends by this one. These are some links I've given here. I'll be sharing this link to Mozi. He can share these things. We have a lot of learning out here. And one good thing here is you have the live labs, right? In case you want to do the hands-on of this digital database, we have the live lab. You want to do the hands-on of rapid replication, we have the live lab. You just go there, click it, launch it, and do the hands-on. And that hands-on have complete workflow. Each and every command are mentioned there. So you want to do anything. I've mentioned here five top live labs. You can try these things. So this is totally free of cost. The thing is there, just click on this, link comes to you, click on the link, and within 10 to 15 minutes, the environment get built up, and you will get the email notification, the environment is ready, you're going to use it, launch it, and you can get all the commands which you require in the scheme itself. Just copy, paste it, and you get output. And below I've mentioned some documentation. If you want to read more on this thing, you can go think. And website, we haven't mentioned these. So these are information can be used for the further reading. Now, I have still 15, 20 minutes to me. So let me start this new concept called True Cache. So True Cache is basically one other feature in Oracle which has it. Like it's again available in 23i only. There's no any backport compatibility for this thing. So let's understand exactly what True Cache is. Okay. Now, in normal days, in today's time, the caching is used to to accelerate the performance application uses to separate from the cluster each cache. Now, example, you may use it Redis cache or the mem cache. Now, these two, I would say, generally we heard the name, right? Now, read the data do not need the most current, because the purpose of the True Cache is we are offloading the majority of the production data, the primary data into True Cache, so that when the application connect to this particular True Cache, you can get data faster. So purpose of offloading the data. We want the most current relevant data in the True Cache should be available from the productions, right? There's a purpose of the True Cache. And here what exactly happened is we have one True Cache instance that's installed there. We have installed the True Cache there. Backend, we have primary database, and the True Cache will connect the application. So application, we get all the read data from the True Cache itself. And all the data we get from the True Cache, it is relevant, up to date from the primary database. This is what we can say about the True Cache. But yes, what the other customer do, what the Redis mem cache do, let's see how that works for them. So write and the current read to go ahead backend, and database is a source of thing. So whatever the data we update in the production database, that should be updated automatically with no time in the True Cache. Okay. Now, if you see the Redis and mem cache, what happened? The developers are responsible for loading the cache, either load the cache at the application level startup, or on each miss cache, read the data from your production database and load the cache and then return the data to application. Now, in the case of Redis and the mem cache, this issue is there. Developer is a main whole sole person who has a responsibility to write the code to ensure that when the application is up and running, it should start loading the data into cache from the production database. And in case if any data miss in the cache, it has to again, some script must be there, which normally can reconcile that what data is in the production, what data is missing in the application level, the caching level. So there is one big burden for developer to ensure this thing. So this is one headache for them, is because what happens is if they do not do these things, they get the stale data, the old data in the True Cache, which normally detail a purpose. Now, developers are also responsible for caching consistently with the database. This is the I'm talking about the Redis cache and the mem cache. Now, cache content will become stale as the RDMS is updated. This your primary data is updated, and if the data is not updated to cache, it will be stale. Now, update done directly against the database that own update the cache. The most applications are not written to manually maintain the cache for consistent, and therefore the work for directly against the cache is increased. Now, if you see my case here, diagram on right side, we have the application, and this application is accepting the below is called your cache, and this is getting data from the database. So what actually happen is the data which is putting from the cache is invalidated. Why? Because the data which present in the cache is not the relevant one, not the latest one. So that's come invalidated. So more invalidation happens, this slowness happens, and you get always old data. That is one thing out here happen. Now, some cache workaround is this by allowing the configuration time to live for different object. In some application developer, they use concept called time to live, means how long this particular object is going to visit in the cache. Now, this is all you can see. It is a manual work. This is all developer managed work actually. There's nothing you can automation. Now, second is developers are also responsible for cache consistency with the other cache. Now, when you read the data from this Oracle, we guarantee that consistency among the multiple value is there. Even if the data is updated by some other process, it will be there. If the application is invalidated, the cache on the update, it cannot update it, because generally the traditional caching, if it is invalidated, so obviously if the data in the backend, let's say, is maybe someone, it's a salary is like showing $10, and the application is showing $5, right? Something like. So obviously the value from both sides are inconsistent. So that reason only thing is the developers have to do a lot of work hard to ensure that whatever the data we have in the productions, the primary database, that should be updated. But that is a very lengthy and the lethargic task to do this thing in the traditional caching I'm talking about it. Now, it also has the limitation is this, it supports the limited data format, like only supports the scalar like string, integer, and JSON. I'm talking about the traditional one. And data cannot be accessed in the column format because it has, if you're looking for analytics reporting, it can only access through the column like a row format. It doesn't support a column format. But Oracle database supports a variety of data types. I tell you, you name it, any data types, Oracle supports it. I mean, the list is very small. I can talk a lot of things. So every type of data type Oracle supports it, and also Oracle also supports both rows and the column format as well, right? Now, developers are responsible for handling that additional data conversion if required. Maybe some new data type has entered. So it's duty of developer to ensure that the data of the data type, it gets converted in the runtime. And the third thing is the JSON document. Now, JSON document, if we talk about the traditional caching, when the data is stored in JSON document, we call it the object cache. The caching problem gets exacerbated. Why? When a JSON object is stored in the normalized table, update to the row in the underlying table should result in the cache invalidation, because updating basically in your JSON is sometimes challenging for the traditional one, because they have multiple issues called different data types and all. In fact, also they have issues with key values things. Maybe sometimes the value is mismatched. In fact, right? And also sometimes you see the data which is there. Maybe the customer say in the like your caching, maybe balance showing me here 1,000, but actually in the database balance is 800, right? So when we have the invalidations of the data in the let's say the caching, obviously the data will not update into the production. And the last thing is they are missing the enterprise grade features, no doubt. uh, they have so much limitation because everything they have to depend upon the developers. All the coding has to done developers. Developer has to write the code, and based on the coding, they have to perform this thing, right? So these are limitations they have. Now let's see what Oracle offers you. Now Oracle has one thing is this is true cache we call is in memory consistent automatically managed SQL. It's a learning key values object. For JSON, we use key value object for caching. Now, develop as a read-only caching in front of the Oracle database. And conceptually, you can say it is a diskless active data guard, no data file required. and data is cache in memory. True cache instance is automatically updated. See, whatever the data you have the primary, it get automatically updated to cache. So the data in the primary data in the true cache, it is can say it is existing the same thing, the same the current one. There's no any kind of invalidations, right? And the true cache handle the all query of the Oracle database, right? Okay, so here it is. This example here. Suppose we have two different true cache instances, even though true cache can be also act as a HA, in fact, high availability as well, right? And it also gives you performance for the read perspective, right? So let's say we have two cache, one for sale, one for HR, right? That this is a database. So whatever the right you have from database for respective of HR, this is sales, you updated here, and the application which kind used to get the latest one. So this different caching instance can be support different data service system. It is there. You can have the multiple services. Maybe one instance we have for sales, one for HR, one for something. When this kind of multi-support or different support of database caching is also is supported by the Oracle database. Now, other thing is you can provide, you can implement this particular true cache into different something called the proximity. Maybe you can have one true cache in maybe US, other true cache maybe UK. Yeah, depending upon the latency, because you have to just a very important thing is in all these is important factors latency, how much latency you get from these two data centers. So you have these options. You can deploy the particular caching out there. In fact, in these two different countries. But yes, as I told you, it used internally as ADG, active data guard, right? So you can place in the country. Now, this kind of services to place the true cache in two different countries, we do not have the traditional, I mean, competitor, in fact. Now, JSON support, right? Okay, now this is very important thing. The true cache mitigate the deficiency of the conventional caching. Now, in the conventional caching, if you see, loading the cache consistent with the database, cache consistent with the value, in fact, all is something called developer responsibility. There are a lot of burden on the developers. They have to take all the responsibility to ensure that every of the operation is met. So the workload increased for them. A lot of code required to do, in fact, a lot of like manual work required to do, in fact. But we talk about the Oracle True Cache. Loading the data, loading the caching is automated. Caching consistent database automated. Not only this, everything automated. The last one, comprehensive security. By default, Oracle has a security. So whatever the security available in Oracle 23i is all inherited to the true cache, right? Parallel processing is inbuilt. High ability is inbuilt. So everything in the true cache is automated or inbuilt. So we do not require any developer to do any kind of activity. Just use the true cache, configure with your application and enjoy. That's it. Everything, the backend is managed by true cache automatically. Rebal their distributions, I mean the data refresh from primary to true cache, it does automatically. And we also tell one thing, the consistency between the application, between the true cache and the primary database is zero. Everything is there. Whatever the data you commit on the primary, it is then true cache. So no any kind of miscache, no any kind of the invalidations in the case of true cache. Everything is to the day. Okay. Now these are the true cache can be deployed, like you can deploy in the mid-tier edge cache, cross region, you can have multiple regions. You can also have the multiple cross cloud cache as well. So this is a different types of deployment option which we have in true cache compared to traditional our competitors. Now, benefit of true cache is many. It improves the application performance without rewriting the application, because in the traditional caching, developer has to write the coding, but here we don't write anything. No investment in the additional caching product or the skill. The same DBA can use it. Just you need to install it, configure it, and that's it. All done. It's very small step. In fact, very small step. We are doing a lot of POCs for True Cache and the Oracle global database across the world. So any of the customer interested to do this thing, we can talk to offline. Single caching for different data types means all data type format. You talk about the documents, relationals, row, column, everything supported. And offload caching to community hardware from the database. Okay. A stronger security, which comes with the Oracle database itself, is inbuilt. It leverages the full power of Oracle database. So all this thing we have, cost reducing performance, scalability, security, redundancy. Let's take last slide. We have a customer. We have one of the world biggest exchange. In fact, initially they were using like Redis cluster, and they were using around 200 Redis cluster. And on 200 Redis cluster, they were doing the caching of 10 TB data only because the DB size was something 200 terabyte. Out of 200 terabyte, they wanted to cache only 10 TB of data. So for that, they were using 200 Redis node. When we did ourselves, when we use our product True Cache, we achieve the same 200 is node within the 6 True Cache instances with the higher performance. So you can imagine the cost wise is saved, I think, because deploying the 200 node for the Redis cluster is required a huge space as well, right? But if we talk about the True Cache, just 6 True Cache instances that got the same output actually. Mobile phone manufacturing companies using the same True Cache. Financial institutions, like everywhere where we have the read related issues, you want to offload the read on the primary, you can use True Cache. Performance specific, you can say Oracle Analytics, good example. OLAP, good example, right? Marketing, Oracle Fusion application, Oracle banking application. The banking, we have a lot of reporting stuff, right? Where you need to put up the report for XYZ. Now, naturally, for report, you put in the report, it'll take a lot of time because you put the data from primary. We use True Cache, that'll be much, much faster than the traditional. So True Cache has many edge compared to performance perspective. Yeah. So key takeaway here is most fully features SQL as a cache. It automates the data refresh and fully Oracle database capability. And it supports leading edge AI such as vector search and the semantic search. Now, a True Cache with a less effort, why still for less? This is the motto for this True Cache. Okay, so I think I've done this thing. If you have any Q&A session.
Yeah, thanks, Habib, for that. I think any colleagues, if you have any questions, you are free um, to ask Habib for this few remaining minutes if you want some clarification. So Habib, we've got a question here from Khalid. What are the benefits of moving from a RAG database to shard database or globally distributed database?
Yeah. Khalid, basically you see the rack and the sharding. These two are the parallel, I can say, HA concept, right? Because rack gives you the same HA option, what sharding does it. So in this case, even though the sharding is not supported by the rack, we are still working on it to do this thing. But the behind the scene is like rack, it has something called a split-based scenario, which we call as a shared architecture. And the sharding is something you can say shared nothing architecture. Every instance is, you can say, independent. It's told as seen my PPT, every shard is a physical database. So the benefit is this, in fact, I don't, discriminate anything. Benefit is sharding gives you better control in the terms of HA. Why it is? I'll give example here. As I told you, if one shard goes down, the remaining shard can take the traffic, right? And the same shard can comes up within a second time. But in the case of rack, if one node is down, a node has issue, it has to evict the clusters, and there could be the possibility of the split brain scenarios, which normally doesn't happen in the case of uh, sharding. And second thing is the scalability terms. If we talk about it, you add more shard, you get the better performance, right? Because in the case of rack, it gives you, but multiple thing comes picture is like the complication of the performance increases, like increases, complexity increases. And the second thing is maintaining the raft replication or the sharding, what to rack is much easier than this thing. So benefits are more actually, even though both are HA solution only, but working and managing operational cost, everything, it is cheaper. And Raft is independent database. It is not rack cluster. Rack has its own beauty, in fact, right? But one thing is that in case if you mix both the Raft and the shard, the one issue will happen is both will be having the option call if a node is evicted. Here, in the case of shard, it get evicted but rejoin back. In the case of rack, it has to kick out from the raft. It has to evict, and also we have to one issue maybe it generates some kind of failure. So that is actually thing. So both have advantage, both are HA solution. Yeah. And sharding is basically is used into 2017, and the 23i has a beauty called graph application, which is something very different from others, right? That is there.
So Khalid, will RAF replace your data guard and Golden Gate in 23 AI when you've got sharding?
Basically, Muzi, I'll tell you just very simple example. Nothing would replace it. This is something called enhancement. Nothing would replace here. See,
Okay.
data guard, it has own beauty. Yeah. And the Golden Gate is a beauty. Now, Raft has its own beauty. If the customer say, example say, we solution deliver solution based on requirement. If customer says, I need a solution where I want 100% active. I can't even bear 1 minute downtime, right? In this case, if you pitch the active data guard, you may fail. Why? Because active data guard takes at least a minute time to switch your from standby to primary, right? Let's say primary is down, you go to standby, even though you have the observer out there, it takes at least a minute or maybe 30 seconds, 40 seconds to bring this up. You talk similarly in the case of your your Golden Gate. In Golden Gate, there's something called conflict resolution detection resolutions. Now, ACD, in fact, that conflict resolution detection and action is option that is there, but that you need to do, you have to code in you have to do something tricking in your code. And also, Golden Gate do not give you 100% guarantee of this thing. You will also lack some kind of few seconds, maybe 10 seconds, 20 seconds, 40 seconds. But if customer says, I can't bear, say, maximum my bearing capacity, let's say 2 seconds, 3 seconds, not beyond this. In that case, we use stock application, which gives you 100% active. Because in that case, we do not have something called active passive. Everything is active. So what happens if one node goes, one shard crashes, you remain two shard can serve the traffic. So that is one beauty in fact. So it depends, Muzi, different types of customer and different use cases. In India, we have something called UPI, Unified Payment Interface. There, every month, millions and million transactions hits to the portal. Now, naturally, if let's say you withdraw money, you pay money to someone, right? And if transaction doesn't complete, let's say within a minute or say maybe 50 seconds, the transaction fail. There, the bank need transaction should complete within 2 seconds, 3 seconds, maximum 4 seconds. That's it. So customer, when we have such a situation where the RTO, RPO, or you can say zero time downtime is a main concern, where they can bear maybe 1 or 2 seconds, they will pitch the route application. Otherwise, Golden Gate ADG remains smoothly as is in fact Yeah. So yes,
Okay.
Khalid, yes, in the
Yeah.
19C, yeah, yeah,
Yeah.
the question with this thing.
Yeah. Yeah. So thanks very much, Habib, for the presentation. I'm sure all of us have gained quite a bit from the presentation. It was a bit technical, but some of us love that technicality. Yeah. So we thank you, colleagues, and for enjoying and sacrificing your time. Hopefully, it was worth it. And to Khalid, thank you very much for also staying up until late to present
No,
this SIG to us. So thank you guys very much.
thank you, thank you
We'll
very much.
close the thing now. Yes. Thank you guys.
Thank you very much. Have a nice day.
Thank you.